This is question 4 from exercise 7C. A garage keeps records of the last 94 cars tested for roadworthiness. The main reasons for failing the test are faulty tires, steering, or bodywork. In total, 34 failed for tires, 40 failed for steering, and 29 failed for bodywork. 11 cars failed for other reasons. 7 cars failed for both tires and steering, 6 for steering and bodywork, and 11 for bodywork and tires. The owner of the garage wishes to calculate the number of cars that failed for all 3 reasons. So let's fill in the information that is given to us into this Venn diagram. So the number of tires is 34, number of faulty steering is 40, and bodywork is 29. We are writing those numbers always outside the circles because filling it in is going to be very confusing. For example, this is the tires circle, and it's comprised of 4 different areas. That one, this one, and here the larger area. So where do you write 34? Here, there? Well, nowhere actually, because we're going to break it down into other numbers. So total tires 34, total steering 40, total bodywork 29. They're actually also telling us that 11 cars failed for none of these reasons. So we will have to put in the bottom right hand corner, and U is the sample space, and the total number of cars tested is 94. So that's some of the information. Let's keep reading. Well, 7 cars failed for both tires and steering. Here's the tires circle, here's the steering circle. Where do they overlap? Well, they overlap in this area, don't they? That overlapping area is 7. Again, I'm not going to write 7 either here or there because it's not right. This overlapping area consists of 2 smaller areas. So I'm just going to go ahead and add a little arrow here, and I'm going to go 7. It's just for me to remember because I will be calculating it in a moment. Then they're telling us the steering and bodyworks, okay, overlapping is 6. Both steering and bodywork. So it's this area in the middle, okay, and 11 for bodywork and tires. Bodywork circle, overlapping tires circle, exactly where? In this area, So that should be 11. Okay, in fact, in the sub-question A, they are suggesting to us to use X to represent the number of cars failing for all 3 reasons. Where is the juxtaposition for all 3 of these circles? For all 3 reasons? Well, it's this middle bit, isn't it? That's where they overlap, all 3 of them. So it's this area that we're going to call an X. Usually, this is going to be our strategy with Venn diagrams anyway. The center, the overlap, if we don't know it, we will call it an X, and then using that X, we will consecutively fill in all other areas. Let's do exactly that. Look, that's 7. This area is 7. Part of it is X. So what's left? Well, 7, all of it, minus X. That's what I'm going to write in that area. By the same token, this is 6, all of that. One part of it is X. What's the remainder? 6 minus X. Okay. And again, 11 is this common area between tires and bodywork. Sum of it is X. Remainder, 11 minus X. I'm now going to remove that information because I don't want my Venn diagram to be too overcrowded with numbers. Okay, that's it, they're gone. Well, what about those areas here? So tires only, steering only, exclusively bodywork reasons, okay? We can apply the same logic. We just need to keep going, right? If the whole circle for tires is 34, sum of it 7 is 7 minus X, Another area is x, another one is 11 minus x. So we can construct an algebraic expression for that one as well, which is 34 minus this, and minus this. Okay, let's see what happens. So 34 minus, in brackets, 7 minus x, always include brackets. Always take your, particularly the expressions that have more than one term. This is one term, these are two terms. You have to take it in brackets, particularly if there's a minus before that. And minus 11 minus x. Well, now we need to remove the brackets or expand. How do we expand? Well, 34 stays there. Minus bracket 7 minus x. So we need to distribute that minus. Essentially, it's like minus 1 times the bracket. You can view it as not just negative, but negative 1 times opening brackets, okay? So that minus should be multiplied by each term inside the bracket. The first term is positive, the second term is actually negative. So minus times 7, positive 7 is minus 7. And negative or negative 1 times negative x is positive, right? Negative times negative is positive. Minus x, because this is minus and this is positive. Negative times positive is negative. Again, negative or just negative 1 times positive 11 minus 11. And finally, negative times negative is positive plus x. Now what we can do, we can collect the like terms, okay? 37 minus 7 and minus 11, okay? So 37 minus, 34, sorry, minus 7, that is 27. 27 minus 11, it is 16. Well, what about the x's? We have a plus x, a minus x, and another plus x. All right, plus x minus x, these two actually will cancel each other out. We're left with positive x, so 16 plus x. So I'm going now to go ahead and literally write 16 plus x into that area. Okay, once I've done that, I can repeat this exact same process for the other two. So for S, for example, what's total steering problems? 40 minus, well, 40 minus what? These three little areas here. So minus 7 minus x, minus 6 minus x equals, again, 40 minus 7, this time is positive, then plus x minus 6 plus x equals, well, 40 minus 7, 33, minus 6, it is 27. 27, again, positive x minus x. Cancel each other out, you're left with just plus x. So 27 plus x is that area. And finally, let's do this last one for the body work. 29 minus 11 minus x, okay, and minus this area, 6 minus x, minus x. Okay, that equals, is that equal to, that's 29 minus 11 plus x minus 6 plus x. And that equals to, just move my camera, okay, 29 minus 11, that is 18, and 18 minus 6, that is 12. And again, plus x minus x go away, plus x. Okay, 12 plus x, 12 plus x. Well, now having done all that work, we're thinking, well, there's so many x's. There are so many x's here. It seems like it didn't give us any good answers. But we need to employ the following tactic. We need to think about it logically. Look, all together, everything, for whatever reason or even no reason that we know of, these cars failed, the total number of cars is 94. So it would be reasonable if we just took each of these areas, all of them, without missing anything, and plus, not forgetting those 11 cars. If we added them all up together, that should equal 94, shouldn't it? Let's try that and see what happens. Okay, so let's just, so that I don't miss anything, I'll just add first those 3 big areas, and then these 3, and then the middle and the 11. Right, so 16 plus x plus 27 plus x and plus 12 plus x. Right? Okay, then plus those 3, okay, 7 minus x and plus 6 minus x and plus 11 minus x, okay, plus the very center, the middle bit, x plus those 11, and all of that must come to 94. Now, because we don't have any negatives before these brackets, okay, we don't need to worry about removing them. We can just get rid of them and it will be exactly the same. So it will be like 16 plus x plus 27. So I'm just to save me time, I'm going to simply erase them. Why? Because these are all pluses. Nothing will change if it's a plus inside the bracket. Nothing will change, because plus times plus is just plus, and plus times minus is still minus, is still negative. Okay, so all of them are gone. All I need to do now is to add them up together. So 16 plus 27 plus 12 plus 7 plus 6 plus 11 and plus 11, and all of that should come to 90. The x's, there are so many x's that are positive and negative. Why don't we just try and cancel some of them out, like in pairs? So plus x, negative x, that go away. This one and that one can go away. Those and 2 will balance each other out. And we're left with only this one x here. So 90 plus x equals, well, 94. Now we need to isolate x. What do? We need to subtract 90 from both sides so that I don't see that 90 anymore there. So minus 90 here and minus 90 there. X equals 4. Excellent. Well, x equals 4. I'm going to erase that x now. In the middle, we found the very center, the overlap of all 3 circles. Now, we're going just to substitute 4 everywhere into those x's. Okay, 7 minus x, 7 minus 4 equals 3. Okay, 6 minus x, 6 minus 4 equals 2. And finally, 11 minus 4 is 7. Okay, same here. 16 plus x means 16 plus 4, and that's 18. 27 plus 4, 31, and 12 plus 4 is 16. We now know all the numbers. What is the next sub-question here? B, hence calculate the value of x. Well, essentially, we've already done that. Okay, we filled in our Venn diagram and we successfully calculated the value of x. C, hence find the probability that a car selected at random from this dataset failed for at least 2 reasons. Well, first of all, they're asking for probability, not for the number of cars. Please pay attention to this. These are just numbers of cars. These are not yet probabilities. But it's easy to find probabilities of each of them. Here, all 3 reasons. It's 4 out of 94. So each of these numbers over, in a fractional form, for example, over 94, the total number of cars, will give us the probability, okay, respective probabilities. And therefore, now they're asking us to find the probability that the cars have failed for at least 2 reasons. What does it mean, at least? Well, minimum 2 reasons. So for 2 reasons is okay, we're interested in that. And we're also interested in 3 reasons for failure. So 1 reason is no good, at least 2. So 2 and 3. Where are the areas for 2 and 3 reasons? There are 4 areas. Well, it's that one, because it's 2 reasons between tires and steering. Here between steering and bodywork, and between tires and bodywork is that. But also we have the middle area that is responsible for all 3 failures. So we need that plus this plus this plus that. Why are we adding? Because we don't mind, we don't care for which exactly 2 or 3 reasons the cars failed. Okay, that does not interest us. We want to know that it just failed for at least 2 reasons. And because it's an or, so this or that or that or the center, the or statement in probability is always plus, is always adding, isn't it? And is multiplying or is adding. So let's try. Therefore, all we need to do for C is to go, look, I'm gonna take these probabilities, add them up together, and get the answer. So for example, here, 3, probability of 3 cars out of 94 is 3 over 94. It's an or statement, so we're adding 2 out of 94 plus 7 over 94, and finally plus this middle 4 in 94 equals, well, that's 5, that's 12, that's 16 in 94. Well, again, we're lucky here. We have like fractions. What does it mean, like fractions? It means that they all have exactly the same denominator. And when we have like fractions, we can simply go ahead and add up all the numerators whilst keeping the denominator, yeah? So rewrite denominator, they're all the same, and then add up numerators. Wherever we have a chance, a possibility to simplify a fraction, we absolutely must, okay? These 2 numbers, they are even numbers. That means that they can be divided by 2. 16 divided by 2 is 8. 94 divided by 2 is 47. Okay, and that's it. That's your answer for sub-question B. What is the probability that the car chosen at random out of this bulk of 94 cars will actually be either faulty for 2 reasons or 3 reasons, so at least 2 reasons, and the probability is 8 over 47.